Hi, welcome back. So here are our video notes for in week 8. We are on section 5.4 and in our packet that's page 71. And so today we're just going to shorten this up pretty fast and not go over all of this just for sake of time. So we've had a couple formulas. We've slowly been adding them to our cheat sheets. And the one that we talked about so far is just compounding growth, where you're just given a very simple rate. And then we talked about what happens when the interest, whether it's a credit card or a savings account, where when they compound the interest, even though they give you an annual rate, when they compound or figure out the interest, they're going to do it maybe daily or monthly or yearly. So that formula from before got modified by a little bit, and here it is. And the last one we're going to talk about in section 5.4 is what happens when they figure the interest, and that interest is compounded, not daily, not monthly, but every split second. Like it's continuously never going to not be compounded. So you're constantly owing interest or earning interest because they're not going to look at it once a month. And so what happens is the formula from before turns into this. And so the way this works is, again, A of t, that is still just the new amount. You have P, which is again called the principal, which is our old y-intercept. It's our beginning amount. But now what's going to happen is your rate and your time are going to be the exponent. So the rate, remember, you need it as a decimal. And then again, t just means time. All right? So that's your exponent, r and t, and I realize that's really hard to see. But then there's this new part, and that's e, which we talked about. And e is approximately 2.718. But we're not going to use that decimal. We're going to be using our calculator. And again, the easiest e to use when there are two of them, there's one above the division sign, and then there's one above this ln sign. Use the one above the ln sign because that will build the exponent in for you. And it's especially important if you're using an older model where they don't raise the exponent. They just show you kind of like that little mountainy T thing. Okay? And you're going to know to use this formula because you're going to see the word continuously compounding or compounding continuously. So when you see that, we're going to nickname this the PERT formula, P-E-R-T. So as long as you know the parts and where they go in the equation and where E is on your calculator, this should be pretty easy to do. So let's start. So the population of a city is 25,500 and is growing at a continuously compounding annual rate of 7.3%. So continuously, constantly, it's growing at a rate of 7.3. So when we figure it out, it's every split second. So first we're just going to write the equation that models it after t years. No specific years, just years. So the first thing I want to make sure is I turn this into the decimal version that it needs to be. And it's going to be A of t equals the beginning amount, so principal, but it's the beginning amount. And then E, I'm going to put a little multiplication dot. And then in my exponent will be 0.073 along with the time. And I am going to wrap that in parentheses just as a reminder that that is what the calculator should do if you choose the right E. So the first thing we're going to do is we're just going to use this model and find the population after 10 years. So I'll just put 10 in there. And again, I always want you to write down what you're about to type into your calculator just in case you make a mistake. And I'm going to put a little X for a time sign. And I'm going to wrap that in parentheses. So how does this look when you type it in? All right, let's adjust this a little bit so you can see it. Okay, so here we go. I'm going to type in my $25,500 or people. I hit the E, so second, and then the LN button, which is next to the 4, right here. and you're going to see it raises the exponent. Now, if it raises the exponent, I actually don't need to put this in parentheses, but I'm going to do that just to make sure that everyone realizes it should be in parentheses. Times 10, close those parentheses. And this is a population, so I think I'm just going to cut this decimal off, truncate it, and say 52,914 people. All right, in how many years will the population reach 100,000? So going back to my model, that means I should be putting it here in for the new amount. So let's write this up a little better. And when you have something like this, this is the systems of equations. This is where we want to go to the y equals or Desmos, and put one of these in for y1 and one of these in for y2. I really think the graphing calculator is best for this. So I'm going to go ahead and type those in. So I'm typing in 100,000 into one of my y's and the other equation into the other one. You can see what it looks like in just a moment. Okay. So there you go. And then it's all, you can always start out with zoom 6, but remember, the 100,000 is a horizontal line way up at 100,000, and this is only going up to 10. I'm looking for a horizontal line. So my suggestion here is just do zoom 0 for zoom fit, and hopefully we'll see it. So it graphed really fast along the bottom, and now it's doing the curve. So when you graph this, be sure to watch it, because if this weren't black and white, I might have missed that. So if you can't see it, I'll help you adjust the window. But if I go to my window, I want to be able to see the 10,000. So I'm going to drop my minimum maybe to just down to 5,000. But the other thing I need to do is I need to go a little. Okay, so I'm going to pause here for a moment because I'm not on the right screen anymore. Okay, so I figured out what my issue was. I didn't type 100,000 in, I typed in 10,000. So this is what it looks like after zoom 0. So I need to go further right, and I would also like to go a little bit more up. So I'm going to press the window, and to go more right, I don't know how far. Maybe instead of 10, let's do 30. Maybe that's enough. And I need to go further up, so because it's right at 100,000, so maybe I'll put 150,000 and make sure I get all my zeros this time. So now I'm going to hit graph. So there's the line of y equals 100,000, and here comes my curve. And now that I see where they meet, I can do my second trace and choose intersect. I'll just move that cursor over to where it is, and I'll hit enter 3 times. And again, I'm looking for the time. So in almost 19 years, I'll be at $100,000. So, but I'm not going to write the almost 19. I'm going to say in 18.719 years. Okay. Now, if you actually want to know how many months that is, it's 18 years plus some months. I could take 0.719 and take it times 12, and it's about, 8 months, 8.5 months into it. So that's something else you could do. All right, next one. What is the average rate at which the population is changing over the years from 3 years to 7 years? So here what I'm going to do is go back to my y equals, because I really don't want to type this in twice. I'm just going to get rid of that. And then I'm going to go to my table and look for when x is 3 and get that amount. And also when it's 7 and get that amount. And I realize there are probably decimals, but I'm just going to drop the decimals off of here. The decimals just don't fit. So what I'm going to do is write these down as coordinates. And so I have 3 with this 31,743. And then in 7 years, my population is going to be 42,507. And then average rate of change, average rate is just slope. So I'm going to subtract my y's on top. I'll take the 42,000 number and I'll subtract the 31,000 number. And then I'll have to subtract my x's the same way. And so I'm using my calculator. I am just subtracting my numerator as we do that. And I get this. And again, average rate of change is over 1. So I'm just going to divide this. and when I'm done, I get 2,691. So this is just saying that the population, that's population, is increasing, going up, 2,691 each year. All right, last question and then we're done. So throughout the 20th century, the population of giant pandas was decreasing at a continuously compounding rate of 2.5% due to the poaching and habitat loss. So if there were 10,000 pandas in the wild in 1900, what was the population in 1980? So if I just write the general amount, I'm sorry, not general amount, general equation, they actually don't give me the beginning amount, they give me the new amount. So when I go for A of t, that is the 10,000. And then I'll actually want to find that beginning amount of the pandas. See, P is pandas, P is principal. And then it says compounding continuously, so I'm going to have my E. I'm going to put this as its decimal, and then that will be part of the exponent. And when I look at what happened from 1900 to 1980, I actually already know the time that's gone by. And that time is going to be from 1900 to 1980. I know that's 80 years. And this is actually something that you can find two ways. One way to find it is just solve for P. P is a number, and what I can do is actually just type this into my calculator and see what it's worth. So I'm hitting the second LN button. Let me shut that light off. And I can see that whole number is about 7.389. So when I'm done, I have this. There's the P with 7.389. And there's a lot more to the decimal, and I don't want to not have the decimal. I'm just writing that down to show you. And now to get P by itself, I can divide by this. What I don't want us to do is round until we get to our final answer. So when I want to take 10,000 and divide by this whole number, what you can do is hit the second and the negative button. Now I have to turn this light back on, because above the negative button it says A and S, and so when you do that, can I hit it? It will recall your most recent answer, so it's pulling this whole decimal into here. And I can see that the giant panda started at 1,353. So the number of pandas, and because these are pandas, I would probably just leave that as a whole number. Oops, sorry, you couldn't see that. The other thing I could do is, again, go to my y equals. I could put one side in for 10,000. I could put x for this, and then I'll just type this in exactly as we see it. So now I'll hit second ln. I'll put in my exponent. And then, again, you can start with zoom 6. I'm not sure what you're going to see, but watch it when it graphs. So when your little wheel is done spinning, or it might be a line, then, and you can't see two things, then yeah, that's a problem. So what we want to do now is, since I only see one thing and I should see two things, I'm going to hit zoom fit. So zoom 0, and again, I'm looking for two things. So there's my horizontal line of 10,000. There's the other one. And so I already know what the answer is. I know it's 13,000 something, so I'm actually going to have to make my x, because that's what we solve for, be much higher. And I'm going to have it go up a little bit higher. And again, setting the window can definitely be a challenge here. So there's the 10,000. Here comes the line. So when we're taking this test, I'll definitely help you with the calculator. But now I can hit second trace. I can do intersect, move that cursor over, hit enter 3 times. And there's that same number, that 1353 number. So that's how many pandas there were in the beginning in 1900. That's it.